Find the most general form of the antiderivative for the following indefinite integral. So again, the way that this is written here, we can't antidifferentiate, so we want to begin by rewriting this to make it easier to work with. So what I'm going to do is simply rewrite the integrand here, this 2 plus cosine of 7t, all divided by 3. I'm going to pull this 1/3 out to the front. So I have 1/3 multiplied by 2 plus cosine of 7t. So now that we have the constant out in front, we're able to recognize the antidifferentiation rules that we need. So for this first portion, 2, this is just the constant rule. So remember that if you have the integral of a constant k dx or dt, this becomes kx plus c. And with the second term here, we have cosine. So we recall that the integral of cosine of a constant k times x dx integrates to sine of kx divided by k plus c. So these are the two rules that we'll need here. And giving ourselves more room, we're now ready to go ahead and antidifferentiate. So I'll pull that 1/3 to the outside of our integral, and the integrand is just 2 plus cosine of 7t dt, and we apply those antidifferentiation rules. So I have 1/3 multiplied by 2t plus sine of 7t divided by 7 plus c. And so this is our beautiful final answer. And just to make sure that we are correct in our antidifferentiation here, let's check. And so we can check by defining our antiderivative above as a function. So we have y is equal to 1/3 multiplied by 2t plus sine of 7t divided by 7 plus some constant c. And so differentiating here with respect to t, we have dy dt is equal to 1/3 multiplied by the derivative of 2t is just 2 plus we have 1/7 multiplied by the derivative of sine of 7t. So this is 7 cosine of 7t. And then the derivative of any constant is just 0. And we can simplify here. We know 7 divided by 7 goes to 1. And we're left with 1/3 multiplied by 2 plus cosine of 7t. And if we wanted to distribute that denominator back through, we would see that we have 2 plus cosine of 7t all divided by 3, which is what we started with. And so we have officially confirmed that this is, in fact, the most general form of the antiderivative for the given indefinite integral.